Hello, welcome back, Dr. Stalker. Thank you so much for joining us today for another TEU webinar. Hope you're doing well.
Hey, great to see you, Eamon. Thank you for talking today, because it's been a while.
Yeah.
But we did a lot of busy, important things in the past few months.
Great. So, do we want to start real quick, Dr. Stalker, with any important updates that the audience might be interested in before we jump into the number one topic for today? Is talk about some of the webinars that you've got slated, especially the New Mexico webinar to talk about climate modeling in New Mexico. Are there any other things you'd like to give a quick update for the audience before we get started on that?
Yeah, Eamon, I'm glad you asked. The new year started with the first day of New Year on the 4th of January. I didn't want to lose a single day in the new year, so I started building my team. A lot of senior people, well-accomplished people are joining. So we started with that, and we're forming smaller groups with focused areas in the business development and also branding, communication, and a portal that we're developing for online forecasting. And a host of other things. So, those are some of the things that really kept me busy in the last couple of months.
So the train is leaving the station, so to speak, and the TEU train is on its way. I think the having the portal so people can start accessing and leveraging this technology is super exciting, Dr. Stalker. And maybe in our next webinar, we can talk a little bit more in detail about the portal and what all that's about. But maybe one of the things that I know that you've been chatting about or talking about doing is doing a New Mexico climate study webinar. Is that going ahead? Is that planned at this stage?
Yeah, it is, Eamon. But let me make one comment about the train leaving the station. Last year, from our conversations,
yes,
we were thinking about bringing some people or countries as early adopters.
Mm-hmm.
And they definitely don't want to wait too long, because they will be left out. So
right.
I just want to say that's really what's happening.
Yeah. And I think that's always one of the challenges, right? Is that if you wait if you don't get in early, you might get to the back of the queue, and the queue's starting to build up right now. So, and as we know, it's not like as if not a lot has happened climate-wise since we chatted last, Dr. Stalker. I think all we need to do is look at what happened in Texas and the implications of not being prepared for weather events or unexpected weather events can be pretty catastrophic.
Yeah, you make a good point there again about Texas and climate change in general.
Yes.
I will talk about Texas actually. So not being prepared is one thing, but being unable to be prepared is another thing. So there's a distinction there.
Right.
There's a reason why we are not being prepared, not because we're lazy, but because we don't have the science until the Stalker method came along. So that's something that we have to think about. And if you put that in the context of climate, what happens is if you don't quantify climate change accurately, quantitatively, then your measures that you're going to take, we talked about this at length, then you wouldn't know what that would do to the system. So you are also being unprepared there. And there's a lot of push right now, to do some things and bring some investments and all of that. That's all great. I have nothing against that. But in the end, you still have to be able to solve the problem. Otherwise, it's not going to go away.
Yeah.
And that's the reason why being unprepared, not because we are not doing our best, but we don't have the proper science. And that's one of the things that I want to highlight when we talk about the climate studies for New Mexico.
And I think that's true too. You can't be prepared for everything. So you should want to prepare for the correct things. And without the science, I don't think we'll know what to prepare for. I think that's part of what you're essentially saying, correct, Dr. Stalker?
I am, and I have to make this point clear too for the non-scientists. Science is, awesome. We respect scientists. I do too. I'm one of them. But we also have to embrace new techniques, new
Right.
methods in
Yeah.
science. Science is not static. Science 10 years ago or 5 years ago or even 2 years ago is not the same as to what's available now. So those are the things that we have to do. But the general population would not understand that. They would
Yes.
say scientists are scientists, they do whatever. It's not the same. So the Stalker method is essentially not about using the same science that wasn't able to provide the answers. And
Right.
we're developing some things. It's new to the world, not to me, because I worked on this for over 15 years, because I wanted to make sure everything that I'm saying, everything that is going to work for every country and every state in the US is actually going to deliver those solutions. Otherwise, it's really not going to help anyone in the end. So I have to say, being interested in science is great, but we also have to embrace new techniques, new methods that are available in the science also. And that needs to be understood not only by the scientists, but also the general population.
Yes, and the good news is that there is new approaches to the science embedded in the Stalker method, but the bad news is we got a change management problem because people need to get their heads around what that means and for both a society and for the science itself. So thanks to you, Dr. Stalker, we're making that progress, but I agree that there's going to be some challenges getting people to understand the implications of the new science and what it means, especially given that, for example, I have a friend who lives in Australia, in Sydney, and he said they were washed away nearly by these local floods. And all of this kind of once in 100 year things that are now becoming once every 10 year type of things is becoming really challenging. And he said that certainly in Sydney, they're all getting a little bit kind of on edge about what's next. They're kind of, people are saying, well, we had a terrible summer last year and now we're getting flooded out. Like what next? There's a little bit of anxious. They're very anxious over there about the situation.
It's understandable, and I'm sure a lot of folks feel the same way. For example, if you're under pressure to deliver on your carbon footprint obligations for the Paris Agreement, for example, that's all great. But whatever measures you're going to take, if it's not going to deliver the results,
Yes,
that's not good for anybody. Just because
absolutely.
you made an agreement and you made everyone else come together, that's a great undertaking in itself. I'm
Hmm.
not saying anything negative about that. That's actually commendable.
Hmm.
But we still have to solve the problem because that's the center point about this whole thing. So
And I
unless we
think,
use cutting edge solutions, we wouldn't be able to solve it.
so, Dr. Stalker, I think that gets back to your idea about use cases and how you can use your technology to actually address the problem itself. So you develop the science, you understand the nature of the problem, and then you use these use cases to basically get at eliminating the issues. Is that correct? How you see it?
It is correct, and that's exactly what we're trying to do with New Mexico,
Okay.
where I spent the last couple of decades
And
living
I have
there, and you
connection.
spent quite a bit of time there too, Eamon. So I went to some of my colleagues at New Mexico State University and talked about how to engage some of the stakeholders, those who are making decisions, those who are influencing decisions, but in the end, those citizens who are going to benefit from it.
Hmm.
So we wanted to bring all those people together to a webinar. It's about an hour and a half.
Correct.
And I'm not going to talk a lot about technology because that's fine and they can read about it or watch our other videos. But I'll be focusing mostly in the webinar on their feedback and next steps. Because this is really not about talking about some science, it's about actually doing the work. And for us to do the work, we have to get started. So the webinar is really about giving the background on the science, obviously, what we want to do, how we want to do, but really spend more time on the use cases.
Right.
And climate change being one of them. In New Mexico, for example, I listed 10 of those use cases, which may change depending on some of the stakeholders that participate in the webinar. And they might say, how about this? How about that? They will be able to shape the webinar and our approach itself going forward.
Well, I think, Dr. Stalker, you've been very engaged, I know, in the Southwest with the cloud, with all the cloud issues with affecting the rainfall. And I've actually noticed a lot more of that in the newspapers recently, talking about the Southwest and rainfall and the drought that's going on there. Would that be one of the things that'll come up in the New Mexico webinar? Do you think the drought conditions and
yes, in the broader category that I list in the application areas, 10 of them is water. Water is such a broad area, like natural precipitation versus cloud seeding precipitation, and so forth. But I'm finding some things in the weather modification arena, and there is some parallel to climate change too. Just as I discussed, and that is this: if we are unable to understand the system,
yes,
and living our lives, there's nothing wrong with it. In fact, there's no other alternative other than to learn more. But at least you're not doing anything with the environment. You're not messing with it. So in the climate change world, for example, you're doing fossil fuel energy, or you're taking some measures without understanding. Those are modification of the system without understanding. Right. And I'm against that. Not knowing, right, being ignorant is one thing, but doing something without understanding is another, completely a different matter.
Curiously enough, actually, I saw that there was a study done recently, and you can't quote me on the numbers here, but essentially it said that when you create these very large solar farms, they were talking about it in the context of the Sahara Desert and the greening of the Sahara Desert, and the concept of building very large solar farms in the Sahara Desert and greening the Sahara, that would have a dramatic impact on other aspects of the global economy or the global climate potentially. So the use cases are kind of, oh yeah, let's green let's build some supermassive solar farms, actually could have, if they're big enough, could have an actual appreciative, quite an impact. Because I think the study said that like the air over the it's going to go up, like the air above they think that the air above a solar farm in the Sahara would be about 2 degrees Celsius higher than the surrounding area, because it's like absorbing the radiation, I guess, and in some it's turning into heat. It's not reflecting back as much, I suppose. But the bottom line is, if you do that on a big enough scale, that's going to have a significant impact on the climate in that area. And it can also have an impact on the role that the Sahara plays in the broader climate loop that we have today. It said something about the fact that the winds coming from the Sahara affect the Amazon. I don't understand all of the impact, but it does seem to say to me that the use cases need careful study, I guess, is the point.
Yeah, so because it's a fluid, and we talked about this a lot, there's always a feedback to what you're doing.
Right.
So it's really not about what's happening in your location and you're happy with it. That's really not how the fluid works, because you're sharing that fluid from elsewhere. Mm-hmm. It's either bringing that to you or you're transporting something to somebody else. So because it's connected that way, you really need to understand the whole system. And unfortunately, the current science in its form, and I have been talking about state variables. In fact, I'm comfortable to call it state variable science without the reference to the underlying physical processes, which are really responsible for the variability that we see in state variables. So, I'm comfortable calling it state variable science, and I'm pushing the boundary into what I call a paradigm shift. And we talked about creating a larger sandbox for all of these scenarios to be played out, and right, also understand what the linkages might be. and the feedback and things like that. So that's something that we need to have if you want to be effective in your measures.
So it's not going to be a free lunch necessarily. Some of these use cases, we really need to understand the dynamics and the interrelationships. I guess is what you're saying, because I see that, like, certainly New Mexico, I guess, could be similar to Saudi Arabia, where I believe they're planning some very massive solar farms, like, kilometers size, many kilometers, like a 10,000 gigawatt solar farm. That's a pretty big area. Like, these farms are getting pretty significantly huge. And I know you've done a lot of work too on I think you told me once that there is also fluid dynamic impacts of the actual wind turbines too, so the wind turbines themselves can actually, as they get supermassive, can actually change the fluid dynamics as well. Is that true?
It is true. And let me touch on the solar piece first. So in the context of New Mexico, it does have quite a bit of solar potential. And a lot of the lands are owned by the state too, unlike other states in the union. But they have not focused on surface, resources. They've always looked at oil and gas,
right,
which is a significant, portion of their revenue. But every time oil prices go down, and which could be because of what's happening in the whole world, New Mexico gets the brunt of it because they rely on that so much. So they need to diversify that into surface resources, wind and solar combination. And funny thing, in fact, the method I got a patent on is really conceived about New Mexico's situation, where it has a lot of this resource, but not a lot of population, relatively speaking, and no load. But I created this concept where you don't really need to have the load. You could actually service others from elsewhere. And that's another topic we'll talk about. But in the context of solar, yes, New Mexico could do it, but do it with smartly. They don't have to slap together a bunch of solar panels or wind turbines and scratch their heads later on what happened. You need to understand that fully ahead of time. And that's essentially what I want to talk about in this webinar, when we do the webinar later in April.
So is it true then to say that we've covered one of the topics then, which is water, and another topic of the New Mexico webinar will be energy? Is that a fair statement? And so or are they related, or are you going to relate the use cases, or are you just going to knock off the 5 or 10 use cases? How do you see these things connecting? Because it sounds like
they are connected, obviously, because it's happening in the environment. Within the first 2 to 3 kilometers in what's called the planetary boundary layer. A lot of what we do as humans, we do mostly in that layer, and we're affected by it, of course. Everything else that happens above that layer comes to the surface, and whatever we do goes to the top and gets circulated and so forth. So you need to really have a fully robust system to be able to model the entire depth using the Stalker method. But relation between the application areas, that's always an interesting thing to think about. And that's really why a system-wide thinking like what we want to employ would be quite beneficial.
So with the use cases, we'll be able to take the model and essentially model out what the implications are of the use case, and maybe play around with the model to see what the impact of different use cases are and how the use cases might interact with each other, or is that true? So, like, I think this is one of the things you may be pointing out, is that you really need to you can't model a use case in an island. You really got to model the use cases within the context of the overall state model, and then basically simulate what the impacts are across the different use cases on the whole model. Is that a correct statement?
That's absolutely true. That's how it should be approached. So we have listed 10. One of them have been water, and then energy and their relations, but also for New Mexico, Eamon, as you live there, it has, these visibility issues due to dust, especially in southern New Mexico, where the visibility goes to zero almost when you have those storms. So you need to think about that. And then of course, hurricanes, for example, coming off sometimes, we think in New Mexico we don't get affected by it. But New Mexico's precipitation is low, especially in the southern half of the state. One dose of hurricane precipitation would dash their yearly average.
Right.
But that's a hit and miss. It doesn't happen all the time. So when it does happen, you need to know and how to manage that. So those are some of the things that we want to talk about. But I want to point out something else, Eamon. So doing the 30-year simulations for 1 kilometer resolution using our method and the RESPR platform, that's a big piece of the whole undertaking. But I want to put the focus on the benefits. What is the state going to benefit from, or any other state or any other country, for example? We want to actually offer these webinars to any country that wants to come and learn more about, what we want to do and how they might benefit from.
So so for anybody listening, this is a service, the webinar service, where we can talk about the use cases and talk about the climate modeling for a particular area. We can offer that to other stakeholders that might be interested.
Yeah, it is. We are going to roll out the webinar as a regular feature. It is going to be for an hour and a half, but I only want to take the first 30 minutes or so to describe the technology and the products they get. But I want to devote the rest of the time to get feedback from the participants and also define next steps. Remember, this is not about giving us a lecture and making them feel better or making myself feel better. In the end, we have to get the thing done, and that's the only way they're going to benefit from. So I will talk about the 3 buckets of benefits, Eamon, that I want to touch on these webinars. And one is, when you have this data set along with the expertise that goes with it, you're looking at 3 buckets of benefits. Bucket 1 being optimizing your resources fully, unlike now. So when I say optimization, you're optimizing full use of your wind resource or your solar resource or your water resource. Unlike now, that's not possible with the current state variable science. So let's make that clear. So without that, you wouldn't be able to optimize. So that's one of the main benefits that you get after going through this exercise of creating the data and applying it to various application areas that we identify. That's one benefit. The second bucket of benefits, Eamon, is loss mitigation. You have losses due to heavy precipitation or lack thereof, or dust,
we've seen a lot of that.
visibility issues, air pollution, you name it. All of those things have negative impacts on your bottom line. So when you understand what they are and how to mitigate, how to take some measures to get away from those losses, that's another benefit also. So that's the second bucket of benefits that I talk about. And the third one is climate change, the all-encompassing, all-consuming topic now. Climate change everyone wants to talk about. But if you don't know how to quantify it, which you will not using the current science, you will not be able to do anything about it.
Which is why I think just two follow-up questions to that, Dr. Stalker. A minute or two ago, you talk about the resolution being 1 kilometer. Can you just give the audience a little bit of a quick note on how much finer the resolution is in your models than they are on the competition? Because I think that's an important point, because that people may not understand how fine-grained your models are vis-a-vis some of the other approaches that are going on. Could you talk about that just for a second?
That's actually a great point, Eamon, and also not just the resolution itself, but the Stalker method is on top of that resolution too. But just purely from the resolution standpoint, some of the data sets that we have in the US since the last 15 years or so, maybe 12 years, maybe 15 years, is about 12 kilometers for the country. And there are some regions where our government does about 5 kilometer resolution data sets also, but not for the entire country. But that's just in the US.
Would that be a 25 square kilometer, or is that a 5 square kilometer, or is it is that a 5 square kilometer, Dr. Stalker?
It's a 5 square kilometer. So right. You are talking about a 25 square kilometer box versus 1 square kilometer box.
Right. So it's a 25x difference.
Yes. So that's one, but only for certain regions and only in the last few years. But before then it was 12 kilometers. Even before then it was 32 kilometers, and before then it was almost like 100 kilometers. So it's been, it's steadily getting better. There's no doubt about it. But that's just on the resolution story. What is missing, even at the same resolution as 1 kilometer, without the Stalker method that focuses on the underlying physical processes versus something that relies on interpolating or extrapolating, they're not just the same. I mean, the maps may look the same, 1 kilometer, but one is more robust.
Right. Yes, absolutely. And you've got all the variables in there versus 1 or 2. You've got all of the information. You can derive the variables from the underlying forces and stuff that the state variables, as I think you refer to them as, are outputs rather than inputs, if you will, of your model.
Right. The analogy that we try to use, it's a challenge for a topic of this complexity. If it's a scientific discussion, I would be, using all the jargon, but I don't want to do that because I want these videos to be understood by pretty much non-scientists who have a good sense of what's going on. They may not be able to derive equations. They may not be able to do the math or understand critical thinking and all of that stuff, but they understand what's going on in the world. When they say change, and if they say, well, we cannot actually quantify that change, they would understand it. They don't have to understand the equations, the system that goes underneath, but that's really why we're focusing on the non-technical discussions here.
Right. And just one final question, Dr. Stalker, before we because we're close to the half hour, and I want to make sure we respect your time here. But you mentioned the final big one being climate change. I see a lot of people talking about decarbonization. When I listen to you, it strikes me that decarbonization is a gross oversimplification. Is that how you see it? That it's really like, while that might be like that. When you say we need to understand climate change and New Mexico, the big climate change, and I kind of just jumped into my mind, that's more than decarbonization, correct? You've got a bigger vision on it?
It is actually true, Eamon. When you decarbonize the system, you really have to know what that does to the system. Okay, so decarbonizing or putting more carbon, if you don't know how to quantify either of them, you really need to leave the system alone. That's really what it is. It's not putting more carbon is good, or taking carbon out is good. Either of those scenarios is not good unless you are able to quantify it.
Right.
And that's really the bottom line we're talking about. Otherwise, in the end, you may invest a lot of money, mobilize a lot of people, and all of that stuff is just fine. I'm not against any of that. But in the end, you really have to solve the problem. When the rubber meets the road, as they say, you have to be able to deliver. And that's one thing that we have to be able to do, with the cutting edge methods that I developed.
And I think that's a great way for us to finish it up, Dr. Stalker. We need the science, and we need to think a little bit more deeply. And decarbonization is definitely an important topic, but it's somewhat of an oversimplification of what we need to do to get to the other side of this challenge, I think, is what you're saying. And
I am saying that, Eamon, and they're going to be happy by delivering the solutions in the end. Delivering mobilizing the people, the message, getting the money, perhaps that's all fine, but in the end you really have to solve the problem, which is not possible now. And that's what we want to cover in webinars for each and every country. Eamon, I'm willing and very much interested in doing this free of charge for anyone, any country that wants to just learn more about what they could get or how they could benefit from this technology and our expertise. All they have to do is reach out to us. The email address is very simple to remember: info@teu.enterprises. They will get somebody immediately within 24 hours to set up the webinar, and off the rest we will go.
So very exciting. And we'll talk again next week, hopefully, Dr. Stalker, and get into a more weekly cadence again on these important news for folks who are following climate change and are interested in the basically everything that's going on in the enterprise universe. Thanks so much for your time, Dr. Stalker, and Odd, thanks for tuning in, everybody.
Pleasure, Eamon. Yeah, we should do it again. We'll keep it as a regular feature going forward.
Thank you.